wordy question, lots of words in there. A colony of bacteria increases at a rate proportional to its size. In 20 hours, the size of the colony increases from 1500 to 3000. Formulate and solve a differential equation for the number of bacteria at time t hours after the size was 1500. We'll do that first, we'll worry about the rest of it later on. It says here, it increases at a rate proportional to its size. That is where we get our basic differential equation from. Its size is n, and it's increasing over time. So how it is increasing over time is dn dt. That is the rate at which it increases. That's the rate at which it changes. And it says it's proportional to, you should be familiar with that symbol from GCSE, proportional to its size, and its size is n. So, the bit I've underlined gives that. Is there anybody not happy with that at that point? Okay. Can you remember at GCSE what you do if you come across a proportional sign?
Equals to k.
Sorry?
Equals to a k?
Yeah. You replace it with equals k times by. So over here I can have dn dt equals k times by n. So every time you see a proportional sign you replace it with equals k times by. Okay, so I've got my differential equation. That's very simple, straightforward. If I'm going to solve that differential equation going through the steps we went through last week, what's the next thing that I do? Yeah, get all the n's on one side and all the t's on another side. Which side will I have the n's on, left or right? Which is the best side, Tom, to have the n's, left side or right side?
Left.
Left, because there's a dn on the top there already. So you have the n's on the left, so that 1 over n will come down here. Keep the k where it is, stick the t there. That's the separating the variables bit. And what was I doing last week after I was separating the variables? Integrating, yeah. So the next step is integrate. So separate the variables and then integrate. Sunny, you integrate 1 over n with respect to n for me.
N.
Yeah, that's right. And can you integrate k with respect to t?
Does it matter that it's not dk?
Well, yeah, because k here is just a some number, so it's just a number, and we're integrating with respect to t. So imagine that was 3.
Then it goes with 3t.
Yeah, but it's not 3, it's k. Yes, it's kt. That's right. We finished the integrating, so put down plus c. Okay, so there we have a differential equation up here, and here we've no longer a differential equation. There's no dx's or dt's or dn's or anything else in it. Now, we need to find out two things here, really. We need to find out what c is, and we need to find out what k is. So how did we go about finding the values of c's and things last time? Put in two values. So what values have we got?
N is 0 equals 1500, and then it's 20 equals...
Yeah, that's right. It says here, initially, at the beginning, it was 1500 in size. So we can say at time t, the size was 1500. Sorry, at time 0, the size of the population of bacteria was 1500. So if we substitute that in, we're going to get log of 1500 equals k times by t plus c. So that tells me what c is. C is going to be log of 1500 because that bit there disappears. So my differential equation solution has now become this. It's still got a k value in it though. If you go back to the question which you've got in front of you, can you find anything else I can use? I did a substitution here, I'll use some information. Is there anything else I can use? Go on, Billy.
T is 20 hours, 3,000.
Yeah, it says after 20 hours, the colony increases to 3,000. So there's another pair I can substitute in as well. So hopefully this pair will let me work out what the other letter is. So I've got log of n equals k times by t plus log of 1500. So, I want to find out what k is. What can I do here then to find out what k is? Laura, can you help me from here? How do I go and find out what k is?
Could you do ln of 3,000 over 1,500?
Yeah, I'm going to do that in 2 steps. First of all, just bring that log across where it's negative. Then log of something, take away log of something is log of the first thing divided by the second thing. So this is log of 2 over here. So log of 2 equals 20k. Well, that tells you that k then must be log of 2 divided by 20. So I can now rewrite the line I had up here. So that's a bit out of focus. And get log of n equals 1/20th of log 2 times by t plus log of 1500. And I have a new version with no unknowns in it, just my 2 variables, my n and my t. But really what I want is n being the subject of the formula, not log of n being the subject of the formula. How could I rearrange that now? Or what should I be doing if I want to make n the subject of the formula and not log of n?
Can you do everything to the e to the...
Well, you're going the right direction. Yeah, get all the logs on one side and then you can probably do something. So I'll keep that log of n where it is. Next, if I shift this log of 1500 over here, it becomes a minus. And that's leaving me with that t divided by that 20 times my log of 2 on the right. So if I now bring the log of 2 across to the left, where it will be a dividing, that's what t over 20 is. Okay, let's see if that's helpful. Over here, can I combine these logs?
Yeah.
How can I combine those logs?
Combine the top to and then 1500.
Can combine the top, so it's n over 1500 logged. Can't actually bring that one in there as well. The rules of logs are if you were taking away. So actually, I'm going to stick that back over here. It didn't prove helpful bringing that across. So taking that back over that, just moving that wasn't helpful. But now what I can do is to anti-log, or e to the power of, Laura, as you were saying. So this bit over here, because it's log equals, I can just get rid of the log. And on the right it'll be e to the power of that. Now here I've got 2 powers multiplied together. If you think back to main school maths, if you had, for example, m to the power of ab, was there another way you could write that? Thinking laws of indices?
M to the A, M to the B.
M to the A to the B, or the other way around. M to the B to the A. They're all the same using laws of indices, which you did in probably year 9. So over here on the right, I'm going to rewrite this as e to the log of 2. That's my ln2 to the power of t over 20. And what's e to the power of log of 2? Because e and log are inverse functions, they cancel each other out, and that's just leaving you with 2, and you've still got the t to the power of 20 over there. Just write the left hand side in. So finally I can get n being the subject. I can just move that 1500 up to the other side. Do not times the 1500 and the 2 together, because that power is only applying to the 2, it's not applying to anything else. So that's a multiplying dot down there. So I've now solved my differential equation. I've got an equation with no dx's, dy's, dn's, dt's, whatever in them. And I've made n the subject. So it's time to look back and see what the question actually was. The question said formulate and solve a differential equation, which I've done. And then the next part of the question said, what is the size of the colony when t equals 80? So now all I need to do for the next bit, t equals 80, is just substitute in. And you can do that on your calculators as well as I can. And get an answer for that bit. Okay, I can see Laura's got it. Laura, you had?
24000.
Yeah. 24,000. So at time 80 there are 24,000 bacteria. I'm just going to pause this video here and carry on in a different one.